the usual Nginx and Apache stack in front of it. And for deployment, they're using Fabric. And when I got there, they were using a different virtualization provider before Amazon. And one of my first things there was to actually move what they were running onto Amazon's EC2 servers. And so I have a lot of experience with EC2 itself and a lot of sysadmin experience, and not a lot of experience with Chef or Puppet. And I worked with CF Engine a long time ago, but we won't really talk about that. And so I took a look at Chef and Puppet, and I thought I could spend a lot of time learning something new and then try and set stuff up with it that may or may not be the way we'd like it. Or I could just use what I know about Amazon and Python and the Python module for Amazon in systems administration and just write something. So I just wrote something. And basically, that's what this will be about. So the basic interface is some shell commands that are, well, they're actually Python command line, easy install stuff that, it installs things on your path. And that's basically how you interact with it for setting up your stack. And so you can set up, right now we have a few different kinds of servers. So the command here is a little bit different from the slide text because I just edited one and not the other. But if where it says web right there, you say database, it'll set up a new database server using the large Amazon server configuration. It'll set the host name to db10.memrise.com. It'll install MySQL 5.5 from source since there's no Ubuntu package for that yet. Well, there may be now. There wasn't at the time. And then it'll install our special my.cnf file for it. Basically has all of our performance settings. And so we do this for web servers. We do this for our Jenkins continuous integration server. We do it for our database servers. We do it for our Solar text index servers. All the different server types have a different special configuration, and we also have like a really standard common configuration that all the servers use. It installs basically a list of Ubuntu packages and a list of Python packages that everything has, and then there are actual API calls inside this framework now that you basically just add things to Python lists of packages in the configuration, and it'll add those to the lists of system packages for apt, for example, or Python packages with pip that it installs. And we're actually publishing the code for this. I put the URL down here at the bottom. memrise.com/dev is basically our open source coding center where we put up all the different projects we're open sourcing. And this is going to be one of them. The code for this will probably be up later, or early next week. We're doing a massive rewrite of it now to pull all the Memrise specific stuff out of it so that you can just configure everything for whatever your local site policies are. And so there are two, for determining like what kind of EC2 instance to use and which machine image to use, there are two maps, and I will show you in the code for that. Sorry. Let me get something a little bit larger than nothing. There we go. So, right here, we have, so you notice, back on the slide.
Close your eyes.
There. So, on the command, you see it says start instance, which is a command. The first parameter is going to be the type of the server that you want set up, in this case a web server. The second one is going to be the host name without the domain component that you want the server to have. And so, if you look at this map here, we call it instance type here, but really it's server type. So web basically needs an Amazon C1 medium, which is basically a high CPU, medium-sized instance. It's 32-bit. And so, if you go to this other map here, this other dictionary here, you'll see C1 medium now uses our 32-bit image. And for the database, since the database is, we actually do quite a bit in the database. We use the largest instance they have, which is an 8 CPU, 64 gigabyte, 64-bit instance. It's really massive. It's a lot of fun to play with. And so that, it's an M2 4X large, which uses the 64-bit image. So we only have two images, one's 32-bit, one's 64-bit, because those are the two architectures that EC2 basically provides. But they provide a lot of configuration on those. So we set up a database or a web server, and then it looks up like what to use, which this is just a summary of. And then it chooses an architecture image, and then it goes through and sets up basically all the packages, all the custom software we have, and if it's a web server, it'll actually check out our software stack from a Git repository locally after installing the SSH keys we need, and do a full deployment on it and make it ready to go so that when we run our standard deployment script, which basically goes through and updates all the web servers, it gets included in the mix. So, let's step back a bit here. Another architecture we considered was having a central control server, which basically, you would SSH to and run like a deploy command on it. It would go through and check its list of servers that we had running and deploy to those and set up any new configuration that had to be set up. And the problem with that is a lot of times things happen and the servers you have running aren't necessarily the servers the master server knows about. And so one thing that I've found over the years is that master servers, one of the things they're greatest at is getting out of sync with the real world. But Amazon provides metadata tags that you can assign to each instance and then read through the Python API. One of them happens to be a name that shows up in the Amazon console. Others are basically just its free-form string key value pairs. And so what we're doing is we're assigning one called instance type, which basically is a string, which is that first parameter in the start instance command, which tells all the deployment scripts and all the management scripts we have what kind of instance it is. So then when we go to do any sort of systems management, it all happens on our individual laptops. Our laptops will just connect to EC2 and say find out where all the web servers are, and then tell each web server to go do a deploy. So it connects to the web server using Fabric, SSHs to it. It says check out this tag from Git. Upload the static files to S3 if they haven't been already, and then make the new version of the site live. And that actually works really well because there's only really one place that the information is stored on, like what kinds of servers we have, and that's actually in the AWS console itself. So basically, the servers are the source of information about them, in essence. And we don't have to worry about maintaining a separate list of like, well, what web servers do we have today? Well, we might have started a few because we were expecting a load spike, but the load balancer's acting funny, maybe some of them are down or something, and it turns out, well, someone forgot to take some out or any other weird sort of thing like that. So yeah, the metadata tags. We have the instance type, the name, and they're set up by the initial setup instance. So when you call start instance or setup instance, you give it a host name, which is basically going to be like the name you want that server to have. It'll be set by the startup script in etc host name. It'll be set in etc host. It'll be set in the postfix configuration, and then postfix will be configured to a send. I think we're using SendGrid for email. all the email coming from the host will go through SendGrid so that we'll get it, and everyone on the right lists will get it when, like cron job emails come through. Since we set the host name for everything on the host, you don't get weird local email configuration errors like, could not resolve host name or whatever, and so you don't lose those kind of annoying but often important at the least expected time emails when cron is saying, yeah, your disk is full, by the way. Maybe you should check into like Web37 and find out why. It also connects to the Amazon DNS provider, the Route 53, and sets a CNAME record from the hostname.memrise.com to whatever the Amazon hostname is, so that you can use our short internal hostname to connect anything that we're running, and it'll still be resolved anywhere you're at. And it's actually pretty cool because Amazon it had just been rolled out when we did this, and so there was no documentation on it. There was no API, or the APIs were just basically really raw in the boto library. But we figured out how to do it, and it's basically part of our. Anytime we start a server, stop a server using our management scripts, the DNS entries get updated. So even when Amazon changes like the host name, like when we restart a server, we have a command that'll just go through and look at all the metadata tags and look at like all the names we have and force all the DNS names for the servers to be whatever, the name.memrise.com will be a CNAME to whatever the new current AWS host name is. And that has come in handy on a number of occasions. So now we get to what we're doing with Fabric. And so normally I would have some examples for this, but I'm on the internet through my phone, which is a little unreliable, so I don't want to actually do anything that's going to update our site, since it might cut out in the middle. So I'll show some more code and talk about it, and then at the end, if there are any questions, I'll show you pretty much anything we have related to this. I may not show you some of our more esoteric internal stuff, but I can show you pretty much anything related to our deployment stuff. So we're using Fabric, which is a Python execution or command execution environment. It basically lets you run shell commands locally and shell commands on remote hosts, and you can specify different groups of hosts to run one set of commands on, and they basically, you script it in Python for the most part. You say, like, this Python function, make it run these shell commands on the remote host and these shell commands on the local host. And then you just chain those Python functions together. And then you call Fabric from the actual shell and say, run this Python command, which is basically a recipe for running a bunch of commands in a bunch of different places. And so we have a command called deploy. So you say /fab deploy. And what that does, it takes a list of our batch job server, which has to run the application stack. It's running Celery. A list of the web servers. Right now I think we have 25 or something. We have a lot more than when I started, but we're also growing really fast. And the text index servers, which also have to run the full stack, because we're using Haystack with Django. It's a Django plugin for using Solr. So basically anything that's running our Django application needs a deploy done to it every time we do a deploy. And we do maybe 10 or 15 deploys a day. We've kind of eaten the continuous deployment dog food. So it finds the host types that should get a deployment done to it. There are three basic groups. It does the batch server first, which also lets us upload all of our static images to S3. And then it runs all the web servers in parallel if you're running it from a laptop that supports a parallel decorator in Fabric. It doesn't work on some versions of OS 10, so we have to check for that. And those guys, when they do deploy, it takes like 20 or 30 minutes. But when I do a deploy, it takes about 3. It's a lot faster than you can do it in parallel, all 24 at once. And then, just in case some hosts have changed or gone away, or you've added more hosts that aren't yet in the load balancer, it looks at the hosts the load balancer knows about. It looks at the hosts that are supposed to be web servers by checking the AWS metadata tags, finds the differences, and then updates the load balancer configuration by removing anything that's no longer listed as a web server and adding anything that's listed as a web server that's not in the load balancer. It just does the differences. It doesn't basically rebuild the whole thing, so the site never goes down. And the way Django works with ModWSGI and Apache is you can change the code locally all you want, and it won't reload it until you touch the WSGI file. And so we actually update the load balancer configuration after we've touched the WSGI file, so they're all going to be running the latest version by the time they're in the load balancer. And that also kind of works out pretty well, because we get fast deploys. We're running the latest version of the code by the time it is deployed. And then if a web server has gone away, the load balancer is updated automatically, so we stop receiving like health check failure notifications. If someone brought a web server down and then forgot to update the load balancer, it'll be taken care of in the next deploy. And those happen all the time. So yeah, we have people here in Los Angeles, person here in Los Angeles. We have a couple of people in New York. We have, most of our team is in London, and we have someone in Beijing. And so basically 24 hours a day, one of us is going to be deploying something. So we're kind of taking advantage of that fact and building a lot of our DevOps stuff into our deployment script. So it all basically happens automatically. So yeah, the three types of servers. What we do, we assign them to roles in Fabric. So Fabric has this really cool thing. Let's see. They're called roles. So web servers is one role. It's basically a list of all our web servers with the user at, host name, port, whatever the SSH can use to connect to it. So all of our web servers are like, the memrise user at web27.memrise.com:2000. And that's how basically Fabric identifies hosts internally, and then it uses that to connect to the hosts. So what we do, we add all the hosts for each type of server, like for example, web server hosts. We create a list of web servers up here and get web servers, which is really just a giant filter function that looks for all the instances from EC2 that are web instances and that are running. Those are like the two main criteria for something to be a web server and to be deployable. It has to be a web server in the metadata tag. Is running here, checks to see that it's running. The instance is live, it's powered on. The operating system is like functional. And then is web just checks like our metadata tag to see, is this a web server? And if it is, yes. So then this gets a list of all the web servers. It sorts them by host name because we just like sorting things by host name. It's easier to read the output when we're doing serial builds and parallel builds. It's just like basically this crazy soup of random characters because each process writes to the terminal at the same time. And maybe I'll be able to show that later, but I'm not sure yet. And so we have the web server list, and then we have the web server hosts, and then we have the actual web server's role, which is basically telling Fabric, these are all the web servers. And so then, later on, you'll have something like list web servers. This is a really simple one. I might even run this. So yeah, you say fab list web servers. And that will contact EC2, assuming that I'm on the internet. I'm assuming I'm on the internet. And then it'll find all the web servers, get their names, and then list them. Just like that. It's a little hard to follow the way it does the output. but it basically, for each web server, lists the short host name and the long host name. So here we have our full complement of web servers running. Apparently we're expecting to be busy. And then, it does the same thing for celery servers, and I don't think we have something for the other servers. So, right. So now, this is like the meat of our deploy command. If I were to do, that, which I'm not going to do because I'm probably a few weeks behind our repository because I've been working on other stuff, and it'll probably take a while to like sync my repository here with the main repository. But what that would do is basically it'll deploy to the celery servers, which is another fab function, so since the deploys run for such a long time sometimes, fab caches passwords that you enter into it. So we have this thing, pre-cached pseudo password, which will right off the bat ask you for the pseudo password and then store it, so that you don't have to come back, in 10 minutes time and see that your deploy's failed because SSH timed out waiting for a password. And that's always a bummer. So we get that. Push master here is basically a command that syncs up the local Git repository with the main Git repository. It does like the push, pull, dance thing. And then, since the roles listed here include all the celery servers, this function gets run once for each celery server, and we only have one. So this function gets run once. And then it calls our common deploy function, deploy1, which is used for every deployment, which does a whole bunch of stuff. And then it restarts the celery server since it's celery server deploy function. And you'll note here, so if you look at deploy web, for example, you see, like right here, there's this maybe parallel decorator that isn't on the celery server. The celery servers can't be done in parallel because there's a lot of stuff that happens on the celery server that affects all the servers after it, mostly involving uploading all of our static assets to S3. So the celery deploy only gets run one at a time, and since we only have one server, it's fine. Then the deploy web actually gets run in parallel, so it'll do all 26, 27 web servers at once on your laptop and print a bunch of junk to the screen, and then it takes about a minute and a half or 2 minutes to do that on my laptop. And then we finish off by deploying to our Solr server for basically site search. And so, there we go. So basically, the fabric commands handled all the deploying for this. And we have that parallel decorator. It's actually really lame, but it's kind of effective. Basically, if it's Linux, or if it's one of these three systems, we'll do a parallel deploy. But all of the systems get they get basically just a serialized deploy. There's some people are running the latest version of OS 10, which it works fine on, and other people are running an earlier version, which it breaks on. I was running Linux for a long time until I got this laptop, and it works fine on Linux, of course, because, who develops on anything else, really? And so, the parallel stuff really does cut down the deploy time significantly, especially as as soon as we got onto Amazon, we had already outgrown the previous provider. We had 2 web servers there and 1 medium-sized database server. We were struggling to handle 50 or 60 concurrent users on the side. And we got to Amazon. I did a bunch of profiling and found that our bottleneck was not the database server. There were a couple of MySQL things that we reconfigured after doing just raw database benchmarks, and found that even with all these settings applied where the database benchmarks were screaming, when we ran the whole stack benchmarks, it was still really slow. And then we realized, oh, we might need more web servers. So we started up about 25 web servers to see what would happen, and the site suddenly was really fast. And so we found that at that point we kept pulling out web servers from the mix until we found like the number of web servers we could have where the site wasn't painfully slow, and added a few more after that. And it turns out that at the time we did this, we went from 2 web servers as our baseline to about 16 as our baseline. So at our lowest load, we need 16 web servers to handle our application. And deploying to 2 web servers when it takes a minute or 2 per web server is all right. That's maybe 5 minutes time when you count, the Celery server and the Solar server. Deploying to 16 web servers when each one takes 1 or 2 minutes time, you're looking at a quarter to half an hour, depending on all sorts of things. And so at this point we realized, the Fabric version we were using was fairly old and had none of the new features that the latest version had, like the parallel decorator. And so we took that as a sign that we should probably upgrade Fabric, which also had a much nicer API for defining tasks and host groups and roles and commands and all sorts of things. And so I spent a couple of days rewriting the Fabric file from the ancient version we were using to basically something I just checked out of their repository the night before, because I thought, if you're going to go to the newest version, why not go all the way to the newest version? Because then when they release it, everything will already be working. And so I did that, and everything worked great on my Linux laptop, because everyone works on Linux. And then one of the guys was using the latest version of OS X, and he tried it, and it worked great for him. It took like our half-hour deploy to 16 web servers down to like a few minutes. And then the VP of engineering tried it on his laptop, and it failed with a pretty obscure error about some sort of method not being found on some sort of type that we weren't even using. It's like, Unicode not found on type whatever. I thought, well, that doesn't make any sense. And so we tried it without parallel after about a week of him not being able to deploy anything. And it worked fine when he was doing it in serial, so that's when I wrote the magic maybe parallel function. And so, let's see. Right, so the Fabric file, it goes through, it finds, it looks at the metadata, builds lists of servers for each role. Functions are decorated by what roles they run, and it also caches the results, because we end up calling these functions a lot. You'll have like 2 or 3 functions called for all the web servers. So if we didn't cache it, it would have to contact EC2 every time one of these functions got ran in the middle of the deployment, and that takes, as you saw, it can take a little bit of time to do that. So if you're taking like 30 seconds at the top of each function call that is in a deploy, and you're calling this thing 20 or 30 times, that adds up too. So we ended up caching the results. Now, the problem is, we want it to be very easy for us, because not all the people working at the company who might notice that we need more capacity are very technical. One of them is a community manager. He's the one in Beijing. And he's going to be up at hours when no one else is up. And he'll notice problems before anyone else does. But he does know how to run basic shell commands. So we have a fab command that will start more web servers from our pool of stopped web servers in EC2. It'll start them 4 at a time. Every time you run it, we get 4 more web servers. But the problem is, since it's running in fab, this command runs after these lists of servers have already been built. So if you were to then immediately run a deploy as part of the same fab process, it would only deploy to the web servers it knew about. It wouldn't deploy to the new ones that you just created. And so I did a lot of weird, deep poking around in fab and tried a bunch of things, and I got it working. And I looked at it and thought, this is really, really hard. So what we did instead, We just, in fact, I'll show you what we do. Let's see. Start spare web servers. So what we do. All right, so basically it starts a web server. It updates the, it waits for them to actually all be running here. Then it updates the DNS entries. So every time you stop a server in EC2 and then start it again, it gets a new EC2 IP address and EC2 host name. So the old host name we had set up for it won't be right. So here we just force it to be whatever the new one is. And then right here, we basically say you updated the web servers, so just run a deploy again. And that way we don't have to like get down and deep into like the inner workings of fab role lists and everything and hope that they don't change the API in the next release and we break our deploys for a few days while we track that down. So basically, the way this would look, we do fab start spare web servers. I'm going to put a comment in front of that. And then fab deploy. It's not quite a single command, but it's two commands. And one of them everyone already knows because everyone's always doing deploys. And the deploy, let's see. Oh yeah, it calls this function, load balance web servers. Another cool function, it basically goes through all the instances we know about, which don't include the new ones, and checks to see if they're running and if they're web servers. And if they are, then it basically gets a list of servers the load balancer knows about. It figures out which ones to add. It figures out which ones to remove, and then adds the ones that have to be added and removes the ones that have to be removed. This gets run as part of every deploy. Right here. And this is in, deploy right down here. Basically calls load balance web servers. So every time we do deploy, the load balancer gets updated. It's almost like magic. And then, so yeah, this is basically what happens. The side stack gets deployed to all the web servers. The new servers are added. The DNS is updated. The inactive servers are removed. And when servers are inactivated, it's part of like a stop spare web servers command, which is what we use to remove web servers. They're also removed from the load balancer. So basically, that's the last slide, which means,
It's time to
are there any
deploy.
questions?
So when you do deploy after starting 4 more servers, does it deploy to all 20, let's say?
Yes, because it may be that you're not, when you do start spare web servers, you may be running an older version of the tree. You may have an older version of the development tree locally. So it'll basically pull the latest version of the tree that's on GitHub, merge it in with your changes, and then deploy all of that to all the web servers.
Can that have like side effects? Like what if
Well,
what
yes.
if you have some weird stuff that all of a sudden it gets deployed everywhere?
Well, you could do that even if you weren't audited. I mean, if you push weird stuff to your master repository and something deploys, you're going to have weird stuff running on all your servers.
How do you defend against that? To me, that's like a big possibility in your scenario.
It happens in any scenario. It's a
Well,
possibility.
not if you QA it first.
All right.
What's that?
Yeah. I mean, in some environments, having a lengthy QA process is appropriate, but in ours, we're much more interested in getting features out to users quickly.
Are there unit tests?
There are unit tests. In fact, we have a continuous integration server which is always running. So every time someone does a commit to the master repository, Jenkins will pull the latest version of it, run all the unit tests, and let us know if there are any problems. And most people run a subset of the unit tests for deploys too, but our unit tests aren't particularly fast, which is something we're going to address at some point, I'm sure.
Do you sometimes run like some new features for some clients, or do you deploy them to all the clients?
Yes, in fact, one of the other things that we've done is this A/B test framework. So each user, if we have like a fork in our functionality, we have both deployed. And each user, as they go to the site for the first time after this fork has been deployed, will get randomly assigned to one group or to the other. And then each day we get reports back about like, users in this group had these retention figures, they learned these many items, they created these many mnemonics. Users in this other group had these metrics, and then we can compare, side by side, what impact each change in one of our A/B test groups has.
Curious about the A/B test. Is the fork in the master code, or do you have two different branches of code you're running simultaneously?
It's both features will be implemented in the same master branch, but it'll basically be like a conditional in the code somewhere. If user is in group A for this feature, go here. If user is in group B for this feature, go there.
And then one other question, I might have misheard when you said it. You said when you kind of deploy it, you get the latest of, I assume, like the Django app or whatever, everything else, and kind of does a local merge as well and pushes it back to master and then deploys it out?
Right. So it'll do the merge load. We have the master repository set up so that you can't do anything other than a fast forward merge.
Okay.
Or a fast forward push. So you have to merge locally. If there are merge conflicts, then the process stops and it says, you have merge conflicts, fix them. And then once you do that, you just do the deploy again and hopefully everything works. Unless someone else made some changes and it breaks again. Which happens sometimes, like when all the Americans show up in London for, a couple of week-long sprint and we're always churning stuff out during the day, sometimes we do step on each other's toes.
Do you have any, can you use the same features to kind of like push to like a dev bot? Let's say you had something that was going to be longer than kind of a continuation cycle, like a branch. Can you push this stuff to like your own mini versions of those?
We can actually. I mean, we all run the stack locally.
Okay.
But we have a command, deploy staging, which deploys a named branch to our staging server, and then goes onto the staging server, does the whole deploy there. Instead of from like the tip or the head of the master branch, use the head of whatever branch you specify. And the only thing that has to happen before you do that is that this branch has to be tracked on our GitHub repository as well. But we have, basically it's part of like every time we make a branch, we do that. I think we have a script for it somewhere even, but just end up doing it in Git. But basically, yeah, in fact, we've made really heavy use of this because we're just deploying an entirely new item versioning framework, which is basically going to make it easier for people to suggest changes, and then for curators to go through and look at the suggested changes and say, take this one, not that one, take these three, not that one. Because before, people would just have to email us and say, your content is wrong, fix it. Your content is wrong, fix it. So our community manager was fielding 2,000 or 3,000 emails a day after we had some press releases a few months ago, and we started growing really fast. And so we're rolling this out now, actually. And we made extensive use of it on our staging server to find like as many bugs as we could and get people, the community manager and his people using it ahead of time so they could see how it's all going to work. I think it's actually going out next week to the live side. So, yeah, that was all done on the staging branch. Yes?
We were talking about this right before you were talking, but can you speak to why you're using Apache instead of Nginx?
So,
briefly.
all right.
I got your back, but you got nothing.
No, all right. So, we're actually using both. And this decision predated me coming here. They started with just Apache, and everything was too slow. So they added Nginx, and everything was too slow. And now they have two different web servers to look at. In fact, when we set up a new web server, one section of the web server configuration is set up Apache with this site. Another section is set up Nginx with this site, which proxies to Apache. So we're basically running Nginx as a proxy server to Apache, and Apache's doing all the heavy work. Without like slagging on the people I work with who are actually really, really bright in a lot of ways, there's no reason to do it that way. Really, we could just be using Apache, which is actually running the WSGI stack of Django and Apache processes and everything. with the Apache front end, the Apache web server front end, and everything would be exactly like it is now, except with one less layer of administration overhead in between. Now, running both servers is not impacting our performance in any way. So, not only is it not any faster than it would be, it's also not any slower. And so, it's something we haven't really addressed because the overhead of coming up with benchmarks to demonstrate this is higher than the effort of just writing the script once, throwing it in a GitHub repository, and then ignoring it forever after.
Have you thought about throwing Lady into the mix too?
Yes,
So you have
yes,
free
actually,
running?
that came up. I did my second week there. I said, "Oh, I see you're running Apache and Nginx. Should we throw light HTTP in? And maybe we could like get the Zeus framework too, just in case, you know, and then throw in some node action because
Twisted.
yes, Twisted is amazing for this. And it's totally
You could have
asynchronous.
5 running pretty easily.
We could,
Let
and it
him
would not
find it out
impact our
if that's what he
performance.
wants.
Yeah.
Are you doing caching? So on the load balancer, before you hit the web services, like caching RAM?
So, I know we're using memcached, I think, for some logging credentials. I don't know if it's actually helping or not. I haven't benchmarked that at all. We set cache headers on things that can be cached. We use S3 for a lot of the static content, so we set cache policies there, I think. I haven't looked at that side of things much. But on the actual server side, basically, so we did benchmark a lot of, or caching a lot of things. And what we found is that the overhead of pickling and unpickling is far higher than just returning results from the MySQL database, which basically has its entire working set in RAM. So one of the things I did early on after discovering this is removed a lot of the caching code from the memcached code from the application, and things got a lot better. And it was one less part of our stack to worry about. And we actually have memcached running as part of the standard web server configuration. And part of what the deploy does is it gets a list of the web servers that we have running and adds all of those, or not the deploy, the actual Django settings.py file that connects to AWS, finds out which web servers are running, adds all of those to the memcached list of memcached hosts. So basically, memcache is sharded across all the web servers. So when you add more web servers and then run deploy and and then the WSGI file gets updated, all the web servers start using all the new web servers too. But then it invalidates the cache, everything gets dumped, and it's almost like caching is pointless at that point. Yes?
One more question. If you guys deploy a lot more often, I'd like to be able to deploy that fast. But when you have to roll back, let's say that someone's committed a bunch of stuff.
We don't
and you
roll
have-
back.
Never roll back. Just roll
No.
forward.
We did once, and it was so incredibly painful that now if we see a problem, we just go in and fix it, and then redeploy. And if you're rolling back, the time it takes to roll back and the pain involved in that is at least as high as the time that the site's broken and you're pushing like a quick fix to whatever you broke and then redeploying. Yes?
I heard you were saying you guys are using EBS and starting and stopping stuff.
Yes.
Why would you do that if you have the ability to spin up instances? Like, why would you start and stop them if you can just spin up new ones whenever you need them and you can just throw them away when you don't need them?
That's basically what starting and stopping is.
Well, no. Starting and stopping is using EBS, which is like the most unreliable part of the whole Amazon platform. So now you brought EBS in, and you're stopping an instance, and it's sitting there on that block storage, taking up space, and
We haven't had any reliability problems with it.
That's awesome.
And it works. Most of our web servers run entirely out of RAM anyway, so after they boot, they never really touch the disk except for like log rotations. But EBS hasn't caused us any problems, and I mean, we're no Reddit or anything, but we do actually do quite a bit of I/O. Our database server is actually running a RAID 10 array in software RAID on EBS, and it does. I don't know what were the latest numbers. I think we're doing like consistently we're reading 50 or 60,000 K per second. So it hasn't been a problem, and if it is, it's not any different than any other hardware problem.
Well, except that you like, I don't know, were you guys on Amazon in US East in April of last year?
No.
Like, when, like,
No,
yeah,
we
when,
weren't.
like, you lost EBS volumes that you couldn't get at them for 24 hours, and all
No,
these,
we
any
weren't.
instance they were attached to would go down, and they got stuck in a zombie state, so if you wanted to swim new instances, you couldn't because you'd hit your limit, and it was a disaster.
Well, yes, but if you need storage on Amazon, you need EBS. There's no way around it.
Well, that's what S3 is, right?
No. S3 isn't live.
Well, it's, if you go wide with it, you have a way of getting stuff in and out of there. In pieces, you can go wide and it can be really fast. I mean, that's what Heroku does with the write-ahead logs and Postgres. It's just pumping them right up into S3 in real time.
All right. Seems like an awful lot of work when you can just use EBS volumes. And S3 has problems too. So, I mean, if basically when you're using a virtualization provider, you're putting a lot of faith in your provider. And they're going to have problems, but if you did it yourself, you would have problems. If you used any other virtualization provider, you'd have problems. You're going to have network partitions, you're going to have outages, you're going to have hardware problems, you're going to have software problems, you're going to have people like breaking routers just because they didn't mean to. So we understand that there are problems with EBS sometimes, but we haven't run into them. And we have all of our backups in S3, so we can deploy in about 8 hours onto a new zone if we had to. But so far we haven't had to.
Considering the fact that there are alternatives to Amazon, besides what's architecturally bound to Amazon, would your Fabric setup change a lot if you went to a different provider?
Yes. Well, yeah, it would. We're basically using the boto library in Python, which is AWS only. And so we were using a different virtualization provider. They didn't have an API. And so we couldn't do any of this stuff. And so that was one of the big reasons why we went to Amazon, is because they have this well-known API. They support it very well. Everything you do, even in the web console, is still calls to the API. So their API is basically like how everything works. So it's kind of a known thing. But if we were to go somewhere else, we'd basically have to rewrite a lot. And I don't think we're planning on undertaking that anytime soon. We basically, we put a lot of faith in Amazon, for better or for worse. And so that's how it's all working right now.
Do you deploy your development servers in a similar manner, or is it just completely separate setup?
Well, we have the staging server, but otherwise people just deploy, they just work locally. And we have a trim database so that they're not loading our, I don't know, I think it's up to 15 gigabytes compressed database every time they want to test something new. Yeah, I think our compressed backup is growing at 300 or 400 megabytes per day. We're growing fast. It's kind of exciting, kind of scary. So yeah, every time we do a big migration, we have to re-download the dump and retrim it so that people can use it, and that takes the better part of 2 or 3 days. But our schema right now is in a state where we rarely have to do like massive in-place migrations. We're just adding columns or we're adding tables. Anything else?
Thank you.
Thank you.